Alright, so these are the 3 problems that are on your quadratic homework. It's another way for us to practice our word problems. We're going to have one of each on our test: a projectile motion, an area, and an optimization problem. So the first one, projectile motion. If a toy rocket is launched vertically upward from the ground level with an initial velocity of 128 feet per second and its height h after t seconds is given by this equation, how long will it take for the rocket to return to the ground? After how many seconds will the rocket be 112 feet off the ground? Just slightly off my board here. Just going to slide that over. How long will it take for the rocket to reach its maximum? And what is that maximum? Okay, first thing, I noticed when you guys were working on homework as well, draw a picture. No one drew a picture, so a lot of the time you didn't know what you were looking for. And that really can help you, especially when you're talking about the test. So we're going to call this one A, B, C, and D. So I'm going to draw my picture. I have a toy rocket. It launches upward, reaches its maximum height, and then comes crashing back down to the ground. I'm going to draw this in one fluid motion like this. So there's our parabola. Here's the ground, and our equation h gives us negative 16t squared plus 128t. Also look at what your letters represent in the story. T is time, that's our x. H is height, that's our y. They're literally telling you that this parabola can be graphed on an x and y axis. So we're looking for the roots when we're on the ground. And then maximum, that's our vertex up here, which we know how to calculate. So part A, when will they hit the ground? Well, h is going to be 0 when they're on the ground. So I'm going to say 0 equals negative 16 t squared plus 128t. From here, I'm going to use my quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals negative 128 plus or minus the square root of 128 squared minus 4 times negative 16 times 0. I don't have a c, so we have to include a c. 0. All over negative 32. So that gives me x equals negative 128 plus or minus the square root of, I think it's like 16,300 something. 128 times 128, 1,603, or 1,000, or 10,600, 10,000, 16,000. Man, I'm just messing that up. 16,384 all over negative 32. This turns out to be perfect. So what I really have is x equals negative 128 plus or minus 128 all over negative 32. So I either get 0 over negative 32 or negative 256 over negative 32. So I get 0 or 8. That makes sense. At 0 seconds into the journey, it's on the ground. 8 seconds later, it's back at the ground. There it is. Part B. Here's our picture. We know we're here at 0. We know we're here at 8 seconds. I want to find out when will it be 112 feet off the ground? So say 112 is right here. I don't know where it is. I'm just going to draw it in there. We are basically finding the roots. So by setting this equal to 112, and then changing it to equal 0, we have modified this problem in such a way that we now have our roots right here. Here's one thing that not very many people noticed when you were working on the problem. Every single one of these numbers can be divided, including the 0, by at least a 4. That gives us negative 4t squared plus, I believe this is 32t, and then 112 divided by 4 is 28. We can then divide again by 4. So we could have divided by 16. Don't forget that you can simplify any of these problems as long as you do it to every single person. From here, all we have to do is plug it into our quadratic formula. If you're wondering, could we have simplified the first problem that we did today, this one? Yes, you could have divided everything by 16 and made the numbers 16 times smaller. So always be checking to see if you can simplify your problems. So we get negative 8 plus or minus the square root of 64 minus 4 times negative 1 times negative 7 all over negative 2. So 64 minus 4 times negative 1 times negative 7. We end up getting negative 8 plus or minus the square root of 36 over negative 2. So negative 8 plus or minus 6 over negative 2. Split our answer, negative 8 plus 6 over negative 2. Negative 8 minus 6 over negative 2. So I get negative 2, negative 14 over 2. So we get 1 or 7 seconds. So 1 second into the journey, it's 112 feet. 7 seconds into the journey on its way down, it's back at 112 feet. Part C, it asks you to find the maximum. The maximum is all about the vertex and that axis of symmetry. So we have h of t equals negative 16 t squared plus 128 t. We are not allowed to simplify this one because that means we'd have to divide the h of t, which we aren't allowed to do. We don't set it equal to 0 because we're not trying to find the roots. We don't set it equal to 112 or any other number because we're not trying to find the height. We need to know when is it max. So in the picture, we're trying to figure out the time that it's at the max. Now we've already solved half of this. You could probably take a pretty good guess because quadratics are symmetrical. So if it's 0 and 8, halfway would be 4. Let's prove it numerically. We're going to take the negative b all over 2a, our axis of symmetry. And this time, instead of saying x equals, I'm going to use the letter that we've been using, t. It's going to help explain it here in a second. So I'm going to take negative 128 all over negative 32. Simplify that, and t equals 4 seconds. So at 4 seconds through the journey, it's at its maximum height. That's not its height. It's not 4 seconds above the ground. For question D, we plug that in. Negative 16 times 4 squared plus 128 times 4. We get negative 16 times 16, We get negative 256 plus 512. And we find out that nope. Sorry, I was looking at the other number. It is 256 feet off the ground. So at 4 seconds, its max height is 256. Before and after 4 seconds, it is slightly lower. Even by a millimeter, it's slightly lower than this. For our second problem on the homework, the area, again, draw the rectangle. You have the length, you have the width, you know what the area is. You know what the perimeter is. And so you can set up your two equations. Area equals length times width. Perimeter equals length plus width plus width. So perimeter is 2 lengths plus 2 widths. Plug in everything that you know. 168 equals L times W. 52 equals 2L plus 2W. And then from here, we're going to substitute. So I'm going to solve for L. So I'm going to subtract 2W. Divide by 2. Oops. And I'm going to pause right here. This statement right here, 26 minus W equals L. They're saying that half the perimeter, L plus W, is 26. If the whole thing's 52, half of it's 26. Then to find one of them, length, all you have to do is take 26 minus what you know, and you get it. Something that you guys do inherently for a lot of these problems, for a lot of things. If I told you I had 30 bucks, and then later I only had $8 left, you instinctively do the 80 minus 8 to get the 22. If you set up that equation, 30 is equal to L plus 8. 30 minus 8 equals L. The only thing is this 8 is W. From there, we're going to substitute it in. 168 equals L. Nope, not L. Sorry, L gets replaced. 26 minus W. W. Can't solve anything when it's written like this, so we're going to distribute the W. And then we're going to get it to equal 0. Easiest way is just to subtract 168. I'm going to reorganize it from biggest power to smallest power. And from here, because I don't like having my first term be negative, I'm going to divide everyone by a negative 1. W squared minus 26W plus 168. And from there, you can just use your quadratic formula to figure out what W is. I'm going to leave that up to you. Then the third one, I'm just going to set it up and set you on your right path for you to keep going. So small concert venue is reviewing their pricing to maximize their profits. Maximize. They can sell out their 400-person venue by selling tickets for $50 a piece. So in a way, you can think of it like this. 400 people are going to show up at $50 a piece. So they make... Sorry, my lines are just not too good. 400 times 50, I believe that is 20,000. They make $20,000 in their current pricing model, but they really want to make more. So they decide that if they increase their price every $2, they must have asked some people if they would be more willing to go or not go. So people, price, revenue. Right now we're at 450. Revenue was 20,000. Every time they up the price by $2, so $52, 10 people refuse to go. So we take 390 times 52. Those 10 people didn't show up, doesn't matter. They made $280 off the new increase. 380 for the 54. 2,520. And this will continue until it gets to some sort of breaking point where it turns around and you start losing money. The problem is there's a point, like even if we drop the price, 10 more people show up at $48, they actually lose money on that deal. So we're trying to find out when it changes. You could guess and check for these in math class types of problems, but we want to set up the equation that way we can find it no matter what problem we have. So what's happening here is the number of people starts at 400 and we lose 10 every time we increase the price. The price was 50, but we gain $2 every time we choose to increase the price. So 400 minus 10x multiplies 50 plus 2x, and that's our revenue stream. X is just the number of increases. It's not the new price, it's just how many times we're going to increase it. You have to FOIL it. And from here, you're going to find your axis of symmetry. It's going to give you x equals something, but that's not the price. That's the times to increase. So if your answer ends up being 4, that means you should increase the price 4 times. So 4 times the $2 plus the original price, 50. The answer would be 58, but I'm telling you this is wrong for the homework. This number tells you how many times you're going to increase it. You take that multiplied by the increase of $2, add that to the base price of 50, and you got the new price to answer the question.